Okay, so last time we were talking about triggers, right? And so triggers were functions that can be executed automatically when we make some changes to a particular table, right? So they can be flagged for execution whenever we have an insert operation or whenever we have an update operation or delete operation by just specifying where we want to trigger it on, whether we want to trigger it before or after that particular operation is done. And triggers can also be row-wise triggers. So if you want to have a row-wise trigger, we can always say for each row, do these things, or an entire statement level trigger that says that for this entire statement, uh, execute that statement and then execute this particular trigger, right? Okay. There were some nuances to triggers when it comes to different vendors. So some vendors implement triggers such that you are able to execute a trigger even if you are bulk loading data into your database, um, so using bulk insert statements. And but some databases also, some vendors also said that if you're truncating a database or basically deleting multiple rows from a database, uh, those triggers, for example, if you had delete triggers in a database and you're trying to delete multiple rows in bulk from a database, in those situations, those triggers will not be fired. So that was the case in case of MySQL tables or MySQL databases, where if you loaded data in bulk, every insert trigger would fire. But if you deleted data in bulk, every delete trigger, all delete triggers will not fire, right? So we have to keep that in mind. Different vendors have different options for executing triggers. So for example, some vendors can also have the um, can also lack the ability to execute triggers when you're bulk loading data. So that's another possibility. So you have to read the manual and figure out for your particular database what they support or what they do not. For MySQL, just remember that if you're bulk loading data from a insert from a backup file or using multiple insert statements, uh, uh, that is something that your database allows, but deleting values from your database in bulk will not trigger any triggers, so to speak. Okay. So if a trigger is slow or if a trigger has an error inside, some bug inside it that would stop it from executing that particular trigger. Usually you do not get that particular error because SQL is very poor in giving you actual details about what led to that particular query failing. But you have to keep that in mind. On top of that, if your trigger is slow, it might also end up killing the performance of your database as well. We also talked about how triggers can be applied to tables. So, and it is quite easy to create an infinite loop or a chain of triggers that are executed for one after the other. For example, if you had a trigger that updates another table, um, you can also imagine that that particular table updates your table as well using a trigger. And you can see that how it is quite easy to generate a queue of infinite triggers, because one trigger is affecting another table and that table is also executing a trigger that affects your table as well, and that keeps on looping up. Um, we also talked about how triggers can be used to apply constraints to your database as well. That is your traditional check constraints that we had. Uh, so maintaining referential integrity for your database as well. So for example, for any entry in our borrower table, we would want to check whether that particular name or account exists in the accounts table, right? So that we can do by just implementing a foreign key constraint on that table. But if you wanted to, you can also implement that using a trigger as well, right? We can just say that, okay, for every account, so for the new account being added to the borrowers in table entry, check for all accounts in the account table and then make sure that that particular new account exists in that table or not, and then either allow it or do not allow the new entry, right? So we can sort of write our own function that implements um, um, a differential integrity as well. Usually we will not do something like this, but I believe that homework 4 would ask you to do certain operations like this. So if there is some conflict within the foreign key constraints of those two tables about the operation, otherwise allow the particular operation and so on. Or if you want to delete something, you can always say that I will write a trigger that would make sure that it cascade delete all of those tables that it is related to, right? So we can technically write a trigger for it, although it is not recommended because we should always use things that are inbuilt in your database for particular tasks, right? And most likely that your database is using triggers internally to implement such things anyway. So that is something that we need to keep in mind. Next, after this lecture, we will talk about the next lecture that we will discuss would be about database performances and how to increase them. And we will talk about that and we will come to database performance metrics a bit more in detail. We'll talk about database performance metrics a bit more in detail, but that is something we need to keep that in mind. Okay. So triggers and stored procedures are sort of the same thing. One is you call it by yourself, the other is automatically executed. But remember that triggers are only useful when, for example, different things have different capabilities, right? So stored procedures have the capability of accessing hidden tables that you do not want the user to access. So a stored procedure can have the capability of accessing those hidden tables, updating or modifying them and getting you those results. Triggers, on the other hand, do not have that ability to access those hidden tables. They can only access tables that are accessible to that particular logged in user. Um, but again, triggers are automatically executed every time, and as we know, stored procedures are not. So depending upon the use case, you would be required to use either a function or a stored procedure or a trigger. And we talked about this. So you can use it to update or last modified timestamps, or you can modify rows with it. And you can also mainly also maintain another table that maintains, for example, a summary of the entire thing of another table. So anytime any new changes are made to an existing table, you can read through those changes and then update those in a summary table, right? So if I want a summary table that maintains the branch name, the total balance of a particular branch, and the total amount of loan in a particular branch, we can always write a query for it, right? So group by the branch name for all account IDs and then sum up the balances. Or similarly, group by the branch name for all account IDs for the number of loans, sum up all the loans, and then for each branch, we have the total balances, the total loans, and then we can maintain a summary table, right? So that would be a way of creating a summary table. And you can, if you remember that for our project, we also have a bonus point for creating summary tables or something of the like for your own databases as well. But coming back to this, so we can create summary tables using normal queries, but every time we sort of change the original table, maybe I add a new entry to the branch into the same branch in for a particular account, right? Or we change the amount of a particular account in a particular branch. We would like to update that summary table as well. Now, if this was a normal simple view, then that is fine, right? So every time I run that view, it is going to reprocess that entire thing and show us the result. But if we want an actual table for that particular summary, then it would be helpful to actually update that summary table as well, just to keep it updated with the changes with the branch table, right? So what we can do is write a trigger for write basically a row level trigger for all new insert and update operations. And whenever we make any changes to the account table, we update the summary table according to whatever changes are made. So we can sort of maintain our summary table as well. We will talk a bit more in detail about summary tables, because this is something that we will work on for our assignment 4 as well. Okay. So before we move on to materialized views, has everyone sort of played around with writing their own triggers and maybe testing them, or do you guys have any questions about triggers that we talked about so far? Type in yes or no if you have any questions or not. Let me go through the names. So Long, Alex, Bailey, Dennis, Derek, Edgar, Edward, Eric, How, Justin, Taha, Vamsi, Skylar. Yep. So fairly straightforward stuff, right? Okay. So let's talk about materialized views, right? So we already know about simple views. That is essentially create a view that executes certain queries, and that is basically just a new name for that entire query. And whenever we run that particular um, select values from that particular name, that internally that query is executed and the results are sent back, right? On the other hand, a materialized view is essentially a view that is basically a temporary table that is stored in the database itself. It is not a query that is to be executed and recalculated again. It is a hard thing that exists in your database that you can then refer to or view, right? Okay. So essentially, we can think of simple views and materialized views. Simple views would basically be treated as named SQL queries that you would have. Essentially, whenever you have a simple simple view, your database would look at that view and substitute that view's definition directly into the query. Right? So it is just another query with a smaller name. The benefits of that is essentially it allows optimization by your query planner. Essentially, if it is just another query, it allows it to push it down to lower levels, that allows it to get you much faster computation. It can plan around and do stuff that it might even plan to decorrelate that query with the other results that we have, and then get you the final result as quickly as possible. However, the drawback of this would be that if your query is evaluating a large number of rows that goes through the database, then it might be time consuming, right? If we had to compute that particular view again and again, it would be better to have a record of the